Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in 8086 microprocessor. We're going to see the instruction set of 8086. We have already seen the instruction set of 8086. We have seen data transfer instruction. We have seen arithmetic and logical instruction, and today in this video we're going to see string manipulation instruction and process control instruction. And when it comes to string manipulation instruction, the instruction which involves the string operations, that is called as string manipulation instruction. We will manipulate the given string. It can be a byte or a word, right? Whenever we say byte, it is nothing but 8 bits, and whenever we say word, it is 16 bit, right? And this instruction can able to move the string, compare the string, load the string, repeat the instruction, all those things. And whenever we come across the string instruction, it can be represented as S, SB and SW. S is nothing but the normal rotation of string, right? It can if it is S, it can be either byte or a word, right? And if it is SB, it specifically denotes the byte, and if it's SW, it is specifically denotes the word, right? And the offset address for the source operand for this string manipulation instruction, for the source operand it will be stored in SI register, and the destination operand will be stored in the DI register. And I've already explained during the flag register, right? We know about directional flag, where directional flag is used for string operations, right? Whenever DF is equal to 0, what it will do is, like, it will process the string from lower address to the higher address. Similarly, when df is equal to 1, what it will do is it will process a string from higher address to the lower address, right? So df flag is nothing but directional flag, which is specifically designed for string manipulation instructions, string operations, right? So depending upon the status of this df, the SI register, we know that SI is one which holds the source operand for the string manipulation instruction, and DI is the one which holds the destination operand for this particular manipulation instruction, right? So whenever df is equal to 0, what it will do is the SI and DI will be incremented by 1 byte, right? And as well as when df is equal to 1, SI and DI will be decremented by 1, right? It will be decremented by 1 for 1 byte, and for a word it will be decremented by 2, right? So this is the introduction about string manipulation instruction, right? Now we'll see different string manipulation instruction. As I said, whenever we involve the instruction, that the string instruction is about involving a group of bytes or a word, right? And these are the instructions where repeat instruction, the REP is nothing but repeat instruction. The given instruction will be repeated until this condition is satisfied, right? Till CS is not equal to 0, right? This register CS, we already know that it will have the count value, right? Until the CS is not equal to 0, it will keep on repeating the same instruction, which means it will stop when CS is equal to 0. We know that count register is nothing but it will have the count values for loop instructions. I have already said that, right? So repeat instruction is nothing but it will repeat the same instruction until this condition is satisfied, right? So I repeat it, it's not until this condition is satisfied, right? It is till CX is not equal to 0, the same instruction will be looped, right? When it gets dissatisfied, it will go to the next instruction, right? And this is a repeat equal or repeat 0. This is again, it will repeat the same instruction until this condition is satisfied. CS is equal to 0, right? So when it becomes CS equal to 0, then it will stop that instruction, right? Or we can also say that this instruction will be repeated until ZF is equal to 1, right? And repeat not equal or repeat not 0, right? This is REP NE, REP NZ. Repeat not equal or repeat not 0, right? Which means it is used to repeat the instruction until the 0 flag is equal to 0. You can see here it will do the instruction here when 0 flag is equal to 1, but here it is 0 flag is equal to 0. It will continue the instruction until 0 flag is equal to 0, right? Similarly, we have move instruction for yes, SB and word. I already said what is yes and what is SB, what is word. Whenever we say yes, it can be SB or word, right? Move instruction is nothing but it will help to move the byte from one string to the another, right? So it can be a string, an 8-bit string, right? Or it can be a 16-bit string. So it can be an SB or a word, right? So this instruction is nothing but it will move the string 8-bit or 16-bit word. Similarly, COM, yes, SB and PS. It's nothing but it will compare two different strings, right? Whenever we say string, it can be an 8-bit or a 16-bit, right? So to compare the byte, one byte, that is 8-bit, we will use compare SB. Whenever we need to compare a word, a 16-bit word, we will use compare SW, right? Similarly, this is input instruction, that is input string byte and input string word, right? Which is used to give input, used as an input string from the IO port to the memory location, right? So the input is given to the memory location from the IO port. And what is output? Output is nothing but from the memory location, it will be given to the IO port. It can be the byte or a word. Similarly, this is very important instruction, which is scan string, right? Scan string, once again, it can be scan string or SB or SW, right? So what it will do is it will scan the given string, right? And what is the exact operation is, it will scan the string and compare it with the byte in the AL. That is, whatever information that is given, that the string is given, what it will do is it will scan that byte in the AL and it will compare the string with the AL register, right? And it can be a word or it can be a byte, right? I repeat that, it is used to scan and also compare the AL register, the content in the AL register with the given string. It can be a byte or a word. And similarly, load yes, SB or SW, which is nothing but used to load the string, right? It is used to load the string to the AX accumulator, that is 16 register. It can be used to load the AL, that is if it is 8-bit, it can be used in AL, and if it is 16-bit, it will be stored in the AX, right? So these are the very important string instructions. And when it comes to process control instruction, process controller instruction is nothing but it controls the processor, which is nothing but it will set the flag register, or we can also say that all the implicit instruction or processor control instruction, where we will not have the operand, but the instruction itself will have the operand, right? You can see here, STC is nothing but set the carry flag. CLC is nothing but it will clear the carry flag. It will make the carry flag 0. And what is CMC? It will complement the carry flag. And STD is nothing but set the direction flag. CLD is nothing but clear direction flag. STI set the interrupt flag, clear the interrupt flag. NOP is no operation. HLT is halt after the interrupt, right? When the interrupt is set, it will halt the operation, this instruction. And wait instruction, it is used for test pen. It will make the microprocessor to go to the wait state. And similarly, ESC opcode memory used to pass instruction to a coprocessor. Whenever we need to, we have already seen this minimum, minimum mode and as well as maximum mode, where I have already explained all these things, right? So this particular instruction, EX key opcode memory or a register, where it will give the instruction to the coprocessor. And similarly, lock state, we have already explained, where the microprocessor will not give any access to the system bus to the any peripherals, right? So in that condition, so lock instruction, it will execute the, it will block the bus, right? So today what we have seen is, we have seen bit manipulation, string manipulation instruction, and as well as we have seen the process control instruction. When it comes to string manipulation instruction, you have to be very careful in understanding what is S, SB and SW, right? It is more or less the same operation for all the instructions like compare, scan, right, move, all those instructions, but you got to understand What is S, SB and word? SB is 8-bit and SW is 16-bit. Right? I believe this video will be very useful for you. Thank you, my dear students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.